So, first of all, I would just like to welcome each and everyone into this video. So, in this video, we are going to basically discuss a bit about borates, which is an inorganic compound, and we will discuss a bit about the different classifications of borate. We will see examples, and we will try to see some of those industrial uses. So let us start from the initial. That is the definition. What is borate? So borates are nothing but they are oxygen and boron compounds. So when oxygen and boron come close together to form different compounds, those compounds can be classified or can be regarded as borates. So we can also say that borates are the metallic salt of boric acids. That is because in boric acid, if the 3 hydrogen atoms is to be protonated, then the unit that is obtained represents the first class or first type of borate, that is orthoborate, which is represented by the formula or descriptive unit BO3 whole 3 negative. So this particular type of borate is the first classification of borate. Let us take an example of this type of this group of borates. The example is magnesium borate, which is again represented by the formula Mg3BO32 whole 2, which is largely used in industries. It is because this particular type of borate has the magnesium borate that I am talking about has the ability to be, it has a large amount of mechanical as well as thermal durability, and it is because of these two qualities it is largely used in industries like ceramic industry, in industries like detergent industries, and many other such industries. So let us now move on to the next type of borate, which is metaborate. So what is metaborate? Metaborate is again a type of borates which is again subdivided into two other borates. One is linear chain metaborate and the other is cyclic chain metaborate. So linear chain metaborate is represented by the formula BO2 whole to the power minus twice N. So this is the descriptive unit which describes this particular type of borates. So if this unit BO2 minus twice N is to be linked with two other same unit in a cyclic manner, then the borate that is obtained after this linkage gives us the second type of metaborate, that is cyclic metaborate, which is again represented by the formula BO3O6 whole to the power minus 4. So let us take an example of metaborate. An example of metaborate is sodium metaborate, which is largely used in industries. So in industrial uses, it is used as industrial fluid. It is also used in industries like automotive industries because it has an extensive property of being anti-corrosive. Or it is highly anti-corrosive, so it is used in large scale in industries. It is also used in industries to let it participate with reactions with acid degradation products. So these are the some characteristics of this particular type of borate, that is metaborate. So the next borate that I am going to talk about is pyroborate. So pyroborate is a type of borate which is also known as diborates, and the reason being is because when two orthoborate units, that is BO3 whole to the minus thrice unit, join together through one common oxygen. So one oxygen will be common in between these two units, and if these two units are joined through one oxygen common, then the unit that is obtained is called pyroborates. So it is represented by the descriptive unit B2O5 whole to the power minus 4. So there is nothing much about this type of borate, this particular borate. So let us move on to the next type of borate. So next type of borate that I am going to discuss is peroxyborate. So peroxyborate is represented by the descriptive unit B2O2 whole twice OH4 whole minus 2. So let us take an example of this particular type of peroxyborate. Let us take an example. Let it be sodium peroxyborate, which is again represented by the formula Na2 before O2 whole twice OH4, which is largely used in industries. It is used in industries laundry, I mean it is used in products like laundry powder. It is also used in dishwashing powder or dishwasher powder. It is used in industries so as to whiten the toothpaste. Basically, the main reason why it is used as optical whitener is because this particular compound has the tendency to absorb radiation. ये radiation absorb कर सकते हैं, and this because of this particular behavior or characteristic, you can say it is largely used as optical whiteners. So this is all about peroxyborates. So let us now move on to the next type of borate, that is spiroborate. So spiroborate is a particular type of borate which has two rings, and these two rings are connected to each other through a common oxygen. That is, one common oxygen is in between two different rings. Two rings which is again in perpendicular, is these two rings are again in perpendicular to each other. So two rings which are perpendicular to each other through a common oxygen, that is pyroborates. That is spiroborates. Now let us move on to the next type of borate, which is complex borates. And this particular type of borate is largely used in industries, also used in lab for performing various tests. So let us see complex borates. One example of complex borate we can take is borax, which is represented by the chemical formula Na2B4O710H2O. So this is the descriptive unit of complex borate, that is borax. So this particular type of borax is largely used in industries, also used in laboratories, of course, to perform different tests. So let us now discuss a little bit about the structure of this particular type of borate. So in this structure, we can see that there are two types of units. That is, one is tetrahedral and one is trigonal. There are two tetrahedral units and two trigonal units in total. That is, two boron atoms are sp3 hybridized and two other are sp2 hybridized. Total number of BOB bonds, that is boron, oxygen, boron bonds, are 5 in number, and the total number of rings in this structure is 3. Two the same, that is same numbered, that is 6, and one is 8 membered ring. Okay, so borates. Let us now speak a little bit about the chemical properties of borates. So aqueous form of borate, or when borate is borax, not borate, borax. Aqueous form of borax is alkaline in nature. It is because when borax is hydrolyzed, we get two compounds. One is sodium hydroxide and the other is boric acid. Sodium hydroxide, being strong base, gives the basicity or alkaline nature in the solution, aqueous solutions. Also, borax bead test is a test that is carried in large amount in labs. Also, because when borax is hydrolyzed, we get two different types of units which we have already discussed. That is sodium hydroxide and boric acids. Sodium hydroxide and boric acids, that is strong base and weak acid. We know that buffer is nothing but weak acid and salt of that weak acid. So borax can also be used as buffer. Now let us talk a little bit about the test, that is borax bead test. In this particular type of test, the presence or absence of d block metal elements are found out. In this particular test, first borax is heated, in which the number of water crystallizations will be evaporated out. After these evaporations, borax is obtained, pure borax is obtained, and this particular borax is then again heated. And after heating, we will get two compounds. One is sodium superoxide and the other is boric anhydride. And this sodium superoxide is essential compound which will help us to identify the presence or absence of any d block metal elements or atoms. It is because when d block metal atoms or element will react with this particular compound, sodium superoxide, then the metal will replaces sodium from the compound and will form metaborate of d block elements, which will exhibit different colors, and accordingly we can find out the presence exactly the element or atom presence, metal atom present in the solution or sample provided. So these are the characteristics and classifications and examples that I was trying to discuss in this video. I hope at least you have got a little idea about what I have discussed, and thank you so much once again for looking into this video.